Awesome. Good morning, everybody. My name is Michael Haag. I work for an organization that's Red Canary, and I'm M. Haggis on Twitter. I'd recommend not Googling Haggis right now, maybe after this talk. I don't want anybody getting sick. Been with Red Canary since 2016. Before that, I worked for a Fortune 150, and then kind of before that, I worked at an MSSP, doing detection, threat hunting, all of that. So pretty much leading up to where I am today, Red Canary focuses on endpoint detection and response using Carbon Black Response and CrowdStrike Falcon. And so all of our detection capabilities are built around those tools, and we find all the kinds of bad things that way. So today's talk is on Atomic Red Team. This is an open source project that we made to help organizations test their security stack and their solutions that they have. And so more or less, we're just going to go over how to test EDR solutions, how we propose testing it against the MITRE ATT&CK framework, and then just different parts of the tools to help test that. Has anybody heard of Atomic Red Team? No? This is great. Awesome. So we've all invested tons and tons of money into security products, whether it's the next sandbox, the next email gateway, all types of things, down to the endpoint. We're buying new AV products every other year because new AV products have new things that are next gen and ML and AI and unicorn pixie dust. So our current state, right, is we buy lots of things, we put lots of controls and policies in place to try to and prevent all the evils. We assemble Voltron, we try to build this cool security stack that we put a ton of money into. Hopefully it'll evict APT when that time comes. Hopefully it'll detect APT when that time comes. And then we walk away from explosions, you know, or we do Disaster Girl, where it's just like explosion, we're grinning that it's all falling apart. Voltron. So how do you feel about those products today, right? You got a lot of security tools, you got a lot of security. Are you confident that a lot of it actually works? You know, you hear about all these recent breaches, we see everything going down all the time, our data is being stolen left and right, lights are changing. Are we actually confident that these things are actually working? And we believe it's working as it's intended to. We were told it was going to, and right, we bought the marketing that there was this detonation feature. It does every type of product file extension, puts it in a sandbox, gives you this cool sweet report, but APT still gets through. And you just hope that everything's there and it's working as intended. So hope's a feeling, not a strategy. So how do you know it's actually working? It's pretty simple. You test it, right? So you probably went through like some kind of evaluation with this product. You ran it through its paces. Hopefully it was preventing everything, found all the evil stuff. But a lot of organizations don't have like a standard like operating procedure about how they actually test products and what they do to confirm their stack is actually working effectively, and constantly evaluating their detections or making sure things are being prevented as they kind of come out, all the new types of techniques come out. So obviously the standard testing approaches here is we have our vendor supplied test, and this will be like a stack test where it's like, hey, download this malware from our website, you'll just execute it in a VM, and we'll detect it, and we'll let you know on our dashboard. It's like, that's awesome, that's great, it works every time, right? Because it's pretty much rigged, you know, you might as well just pay them to do that all day. You have your in-house testing, which may or may not be the best. You might just go on VirusTotal, download a bunch of ransomware, and you execute it, and then it detects it, or prevents it, hopefully. This works most of the time, and that's where a lot of Atomic Red Team came out. Like the core foundation of Atomic Red Team was we were doing evaluations at Red Canary. Customer or eval come in and say, hey, I want to test you guys. I'm like, oh, awesome. They have a red team, you know, they got an in-house team maybe, security team at that. They're going to do more than just execute malware. I know these guys, right? Hoping they're going to break out like Bloodhound, do some PowerShell stuff, download some Mimikatz, try to go do some lateral movement, do some cool stuff. They end up just running ransomware, and it's like, oh, cool, AV's top #1 thing, you know, and that's where it was just like, I'm over the AV, you know, execute the malware, see if anything catches anything, does Red Canary detect it, you know, and it just kind of goes on and on. And so Atomic Red Team's whole purpose was Let's change that. Let's do something different where you can actually give an eval customer or prospect something they can actually do. And it's not stacking the game in any way. It's an open source project. And so what we're saying is, here, take the different techniques from MITRE. Has everyone heard of MITRE ATT&CK by now? Once or twice? So if you haven't heard of MITRE, we'll hop into that in a second. I'm jumping too far ahead. I'm so excited. So your common approach outside of the vendor stacked game is your annual pen test. You got your annual pen test that rolls through, pen test your environment. You know, you have some kind of problems with it, which is your standard, you know, we're meeting compliance, checkbox. We find the cheapest pen test that we can afford, bring them in. They blow through our environment with a Tenable Nessus scan, drop a nice 8,900-page report of all the vulnerabilities in your environment. It's amazing. It could be expensive too, right? If you get a really, really solid pen test, internal, external, phishing assessment, all of that, lots of money. Then there could be scoping problems. Can we get domain admin? Are we allowed to touch certain web servers? Don't touch those. There's customer data. There's PHI. There's all this fancy stuff going on. We can't let you guys get anywhere near that. And then, of course, not all teams are created equal. You know, you got the Nessus, or what John Strand calls pen test puppy mills. They just kind of rotate through Nessus scans, ship reports, very basic. And so that's kind of where like the really, really solid red teams come out that are out there. Or you can just call HackerMan or wait for China to do it, whichever. So solution, another solution, maybe you just build your own red team. Kind of the hard parts to that is it has its own challenges as well. You either got to build up internally on your own, hire a bunch of guys to come in and learn or who have done it previously. You might end up with a team of like 6 guys and you have like a very small organization. So it may not be completely effective and most cost effective for your whole organization. Even the largest organizations out there have very small red teams. So it's still something that's being built up out there. And so building it versus just running a bunch of malware is almost kind of like 2 different things, right? Which leads us to why Atomic Red Team was formed again. So outside of the occasional poorly scoped pen test and rigged POC testing, many orgs simply do not regularly test their solutions. And that's the beauty of Atomic Red Team, and that's what we always try to push and recommend to organizations, is making sure that you're constantly testing your security stack. Is your AV working as effective as you hope it is? Is that new perimeter firewall, UTM, whiz-bang gadget on the perimeter actually preventing things as it comes in? Or even egress. Are you able to get the visibility of things leaving your environment or posting out to random websites out there? It's all about that visibility with detection. So we need an ongoing iterative testing solution, something that you can actually measure objectively, and then has a very low barrier to entry. And pause for dramatic effect. We've already talked about it. So Atomic Red Team. So it's open source, like I mentioned. The idea of it is supposed to be very easy for anybody to go in and say, I want to be able to test my full security stack from end to end using MITRE ATT&CK. So you can say all the way from the delivery all the way down to command and control. I want to see each stage in my environment of how I have my detection built. If you have an MSSP or if you're using an outside provider, this is a great way to actually see if they do things in your environment. How do they actually respond? Are you getting an alert for a new scheduled task? Are you getting an alert for abnormal C2? Whatever it may be in your environment. And the way we made a lot of these tests is super simple. Like just go to the website, go to the GitHub repo, copy and paste, drop it in on a box that you have access to, and then you're approved to run it on. Run it. See what happens. Did anybody alert you? Are any of your products firing off? Is anybody doing anything about it? So, and MITRE right now is probably like one of the hottest topics out there today. Everybody's been building on this. We started this project last June, I believe now. So we've been working on this and adding things to the framework as much as we can as well. Whoa. So MITRE ATT&CK. Back up a little bit about what MITRE is. We had a couple people nod on it. It's a treasure trove of adversary TTPs. It's mapping of also known group behaviors. The neat thing about it is you're able to go in there and see like APT32 and understand that they run PowerShell, RegServe32. They set up some kind of persistence on the environment and they perform whatever other activities. And that's kind of the nice thing about MITRE, is it gives us that visibility. Can you guys see that side over there? Not that side. I'll come down here. But you can see over here on this side, which is probably your right, this is all the pieces where MITRE ATT&CK has been mapping out to. So we have our persistence, privilege escalation, again, all the way down to command and control. So the focus is down in that post-exploitation area where we're now having visibility into, which is really neat. And the way we did it with our Atomic Red Team framework here is it's on GitHub. It's under Red Canary's page, Atomic Red Team. The way MITRE broke it out was they have Mac, Windows, and Linux. And so we built out all the use cases under each of those folders here, Linux, Mac, and Windows. And each one of those is an actual matrix, the MITRE ATT&CK matrix. And we went through and we built out each one of these different pieces so that literally you could go in, have that low barrier of entry, copy and paste it, execute it, see what fires in your environment. That sounds so simple, right? Like just copy, paste something, drop it in. Most of them are that easy. There are some in here that require like maybe a C2 server on the other end just to get that full kind of like end-to-end visibility of what actually happens. But yeah, you see dynamic data exchange. That was that really popular Excel, Word, DDE exploit and all that. So little things like that are in there, which is really neat. Makes it very effective, super simple. And so the whole idea, again, was to have low barrier of entry. You're able to go in and test your environment, make sure that sandbox actually works. You can do small targeted tests. You don't have to wait for that annual pen test all the time or pay a bunch of money every other year, every year, whatever it may be. But you're able to start testing yourself for different techniques within MITRE. If you want to focus this week on persistence, you can just go down the persistence line. Do we have visibility? Do we have our detections? Are we looking for this within our SIM? Or is our other product pieces actually helping us here in these areas or not? And that's probably one of the most important things, right? Are these things working? And to also give back and help organizations out there get started with these things, have better testing methodologies out there for seeing and proving out these products. Thought I took this one out. So the origins of Atomic just started out, again, just as something where eval organizations can actually just run through and test Red Canary. This is on my GitHub page. It's under Bookish Happiness if you want to just go look at it. It wasn't mapped to MITRE back in the day, which was why we moved to that today, because it's a lot more effective and everybody understands it, has that singular language we're all able to talk. So next couple slides, I'm just going to break down a couple pieces of MITRE ATT&CK and the actual techniques. So this is technique 1117. This is Red Surf 32. There's an R way over there. But you guys ever see any of these types of attacks out in the wild within AV or anything EDR products? Is anybody looking for this? Awesome. This is where it becomes effective. You can go on the website right now, Atomic Red Team, GitHub repo, check out 1117 under execution, Red Surf 32. And you're going to be able to run this quick command. Copy paste it. You have two options within the repo. There's a local command of it, and there's also an external one. So you're actually able to pull the payload from GitHub, or you can just run it locally on the box. And so in this particular case, what we always try to do for everything within Atomic Red Team is we want to be able to break this down and show you different pieces where you can actually build detection around it in your environment. So in this particular case, Red Surf 32 is running on every Windows machine out there. It's super noisy. Executing stuff all the time. Looking just for that isn't going to be the most effective way to detect this type of attack. Maybe you could do it on the command line switches, /s, u, I, maybe just scrub scr DLL. Maybe it's going to this weird website, right? Look up the network indicators. Is it hitting a different port, non-standard ports? Is it going to a domain? Is it just making a network connection in general? Which Red Surf, by its very nature, does not do that. And then that module, scr object.dll. All of that is very fishy. Casey Smith found this, I think a couple years ago now, maybe 2 years now. Anybody know who Subt is on Twitter? Yeah, okay. So he found this. If you've been following him for a while, he's been pushing this one around for a while. So that's where this comes. So within that matrix for Windows under Red Surf 32 execution, this is exactly what it looks like on the repo. you can go in. If you just pull the repo down to your local box, you can execute it locally like this. Or if you want to download it, you can do the remote here. And so one of our examples that we have is you could just use PowerShell, download the SCT, and execute it that way through RedServe. It's really powerful. And then the payload, the SCT file is down here at the bottom. So we give you a very basic example of the payload. It'll just pop calc. So is anybody monitoring for calc execution in their environment? And so using Atomic, the way we see the life cycle is you test your technique. Did you actually detect it or not? Do you have, the pieces broken out? Do you have the telemetry from it? Are you building and tuning your detection capabilities? And it's just a complete cycle. You either do or you don't have visibility for all of these things or some of these things. And so the idea is that you're continuously testing. It's a full loop all the time. And so that's the objective of it. And it makes it very easy to just do one, confirm, and just kind of keep going down that line. Anybody have a Mac fleet in your environment? A couple Macs out there? Cool. So I left this one in here because I thought this was cool. This is Apple Script on all Macs. And this is Technique 1141 within MITRE. And it's input prompt using Apple Script. And so specifically, this is the piece peeled from MITRE. If you go to MITRE's webpage, they give you the full details about input prompt, how Apple Script works. On this side over here, you'll see the platform, what part it's under. So the tactic is credential access. What data sources you'll actually need, and that's a pretty important piece to collecting this telemetry. So in this case, user interface and process monitoring. And the process for Apple Script is Osso Script, OSA script right here. And so this particular technique, this is again from the repo, it's just prompting the user for their password. So if you execute this on your Mac box, it'll prompt the associate for something. And so like in this case, here's the input prompt right here. Back up a little bit. The full script is right here at the top. So this is one way to run it, and this is how we have it in the repo. You just copy it, you paste it, you'll get a prompt on your Mac. Again, is your product out there detecting that input prompt on the endpoint side? Do you have visibility into weird prompts happening on endpoints? So in this particular case, I need your password because we're doing software updates today, thank you. And everybody's gonna enter it, right? So that's how we roll. And then another way you could do it, actually just breaks down a little bit of the pieces here and broke into carbon black response so you can kind of see it. Is anybody using carbon black response or CrowdStrike Falcon? We should drink every time, ask a question. But so in this particular case, Osso Script, that -E right there is probably one of the more important pieces when you're running Osso Script. If you have a Mac fleet, look for Osso Script in your environment. It may or may not be very noisy depending on the apps being used. It's launching system preferences, and then there's your password piece. This comes from Empire, this whole piece right here. So the Empire project was ported into Python, and then they made it just like for Mac and Linux. You can go hog wild with it. So this is one of the nicer ones that they had in there. I believe in the project itself, password is spelled incorrectly, but we always see people enter it anyway. So again, iterating through your testing. So that was very basic. Osso Script, call it, execute it. Another one here too, which you can't really see too well on the far end over there, but it's actually just calling it through shell command. So very simple, just sh echo, and then the whole same command there. So again, another method to see if you can actually detect this. Some organizations might just do like wildcard something, looking for password on the command line variable. It's definitely one way to do it. Could be very taxing on a SIM or even carbon black. So always be testing is the one thing to walk away from here. So, ABT. So one thing that we started getting feedback from the community was we want automation. How can I automate these, simple copy paste, drop it in? How can I make it faster? How can I just run a bunch of things at once versus just copying and pasting and do one-by-one test? So we came up with this thing called chain reactions. And the idea of a chain reaction is taking multiple techniques across the tactics from MITRE and putting them together and just putting it in a batch file or a PowerShell script and just execute it. So it'll just go through, simulate a bunch of weird behavior or activity in your environment, and you may or may not have detection for it. So the quick way to generate a chain reaction is what I always do is I just pick a couple different techniques across all the tactics, and I just say, I want to do some discovery. If I got some credential access, let's throw it in there too. I want to do some scheduled task or do some type of automated collection, and then do some basic exfil. Whether, exfil doesn't always mean, taking it off out to the internet to some Chinese website. It could also just be compressing data and storing it on the box, staging it for exfil. So all those things, I just want to make it happen in one bang. I don't want to have to deal with copying and pasting 12 things at once. So again, here's the MITRE attack matrix. So what we're going to do is account discovery, file deletion. We're going to do some system security discovery. And there's our data compression, encryption, and change the size of it, or slice our zip file up in multiple ways after we collected all your doc files. So very adversarial simulation based, right? You guys find this pretty useful? You guys gonna go home and play with it all night? Yes, love it. Then you're gonna do a pull request, right? Awesome. So this chain reaction is called plutonium. On the repo, it's under Atomic Red Team, artifacts, chain reactions, and this one's plutonium. Very, very basic. We always try to start off with everything, don't execute evil stuff in your environment unless you have permission. And then below that begins all the fun stuff. So in this case, what I did is I just said, I'll hop on the next slide because that's where all the magic happens. All right, so here it is, plutonium. So this is just the raw piece of it. Here's my persistence defense evasion. This is my scheduled task, which you can not see over there. I'm scheduling it, I'm naming it atomic testing. And then I'm gonna have it run redserve32. I'm gonna download the content from our GitHub repo, which happens to be that SCT file. And so it's gonna schedule that job on this box. It's gonna do evil things. It's gonna be pretty cool. And then the next one down is discovery. I'm just having it actually download a bat file that I created, which is called discovery.bat to make it super simple. Discovery.bat has like 80 things of discovery, all the techniques. So net user, net local group, net all the things, right? It just goes down the list. It runs WMIC, just executes hog wild, like just wild, wild stuff. The pieces you can barely see over here is after this, after it downloads and runs discovery.bat and goes crazy, it will then add a user named Trevor with the password of smashberg123, and then it will add Trevor to the local administrators group. And then after that, it says, echoes out, hey, that was real fun, So now you get to go back and try to find all that data in your environment. And I always try to break it down. You can't see the scheduled task one over there, but looking for these types of things in your environment. And this is the power of using a product like, or a simple tool like Atomic Red Team, is now you're able to say, do we have visibility into our scheduled tasks across our Windows fleet? Do we know who's doing what out there? And it's pretty generically busy and kind of noisy at times, but if you filter out the noise, you get down to weird things like this. Are you looking for HTTP that are being scheduled in there? Are you looking for, in your proxy logs, people downloading from raw.githubusercontent.com? And then also executing redserve32 scr obj.dll. All those types of things. Down to, you got people executing PowerShell. They're running download string from GitHub again, and they're dropping weird bat files from the internet, because we all do that for fun. And then we've got to figure out, once they made that file mod, what's the output look like? What are they dumping, right? Actors will dump all their data to a text file, password encrypted, and ship it out. Splice it if they need to. And then, are you monitoring users being added? So you got lots of pieces of telemetry going on here. One of our other chain reactions actually just downloads Mimikatz. So again, did my sandbox alert on that? Did it execute it? How do I know Mimikatz is being brought in? Was I alerted on any of this that's happening out there? One of the reasons why I like this one is you may get a tip-off just based on that scheduled task from some of your standard alerting or even that PowerShell command. But the ones that people don't really alert on or monitor a lot is adding the user and adding a user to the local admin group. There's other chain reactions I created that are heavy focused on discovery. Literally just looks for users, runs a bunch of discovery stuff, and then it downloads Bloodhound at the end and it runs Bloodhound across your AD environment. It dumps the files on the file system. Most of it's so noisy that people don't want to look at it in their products. And that's the power of using something just like as a batch script or a PowerShell script. Makes it nice and easy. So the next thing we did was, well, let's take a report from like Mandiant, like an APT report, and let's simulate it. Because now we got a quick way to take everything we built, put it into a batch file. Well, let's now simulate an actual threat group. So now you're curious, like, let me threat model all kinds of stuff in my environment. Find your friendly neighborhood APT out there that's roaming the streets this week. Let's mimic that actor and then maybe get some profit out of it. So in this particular case, we created another chain reaction in that same directory called Dragon's Tail. We looked at it on MITRE's webpage here. We see that they schedule a task, they run redserve32, and then they use PowerShell. And they do other things, right? They have custom command and control, they do fancy protocol stuff. This threat group in particular changes their tactics and techniques pretty often, almost weekly now. So if you're following along with them, there's a hashtag on Twitter called #DailyScriptlet. Nick and those guys are constantly posting the changes that these guys are performing weekly. So anyway, back to this report, APT32. This is exactly what we built just for that test. And this is a PowerShell script, and it also has a macro you can embed into your Word doc to simulate the execution from Word, spawning something else, and then downloading something and kind of going down that full chain. So this particular case, there's your scheduled task. We're running it, we're deleting it to kind of help try to clean things up because we're nice like that. We'll download more evil stuff here, and then we create a, oh yeah, we do time stomping in here. So in this particular case, yeah, this is really cool. Casey made this to 7/16/1945, where he changes the file date and time on that. And then the defense evasion here is we're just deleting the text file, writing to the host that it's done. So really, really simple to mimic an adversary. We haven't gone through and created all of these from MITRE, all the different threat groups out there, but this is just one quick example. And that's part of the modularity of Atomic Red Team, is you're able to just say, hey, I want to run like 5 things and just see what it looks like in my product stacks, or how's my network? Do I have visibility into this coming in, or ship that Word doc through email? Did my email gateway detect it this week? So I'll do a demo. I think we still have some time. I'll do a demo here in a minute so you guys can see how easy it is. Quick notes on simulating APT is, so this is Nick Carr. He tweeted this a little while back, but it's basically is, I don't know that it's possible to authentically simulate the best APT groups. Best we can do is get up to yesterday, because they're constantly rotating and changing their tactics and techniques. So tomorrow it's going to be something different. They're doing something different. Even just malware spam campaigns, they're constantly changing their techniques to bypass all the gateways. Then we have our Trump tweet here. Russia has tremendous APT, just tremendous. So they have the best trade graph. You can't catch these guys at all, but they're great. So before I hop into demo, what's next for Atomic Red Team? What we've been working on now is making things to where it could be pulled into different automation frameworks. And so in this particular case, over on that side, which is kind of cut off, we've been converting all of our techniques to YAML. So now it's going to be even more machine readable. You're able to now just kind of run through this with whatever product you want to use. Some of the short term is getting it pulled into Uber's Meta automation tool, or even MITRE's Caldera, so you can just automate it across multiple machines in an environment. Makes it quick and easy. We're working on that right now. That's the big one. Lee Holmes over here on this side, he actually put a pull request in, just like what you're going to do here soon too. He put his pull request in that create like a really quick automated PowerShell framework for the current techniques that are in there. We haven't converted that to YAML, but once that converts to YAML, everything will be from Atomic Red Team into like a quick PowerShell script. And you can actually build like your chain reactions right there in the framework. So just ship them off like that. Very, very powerful, easy, free. So there's the repo when you submit that PR. So it's just GitHub, Red Canary Co., Atomic Red Team. There's the website as well, atomicredteam.com. Link right to the repo from there. Everybody's Atomic. This is open source. Contribute, ship anything back. If you have feedback on the project, shoot us an email at research@redcanary.com. You can always hit Casey up, which you can't see, but everybody knows him, at SubT. There's me and then Adam as well, who's working on the project. So do you guys want to see a demo? Yeah. Let's see. Let's screen are you guys on? All right, let's see if we can make it rain. Okay. That looks awesome. So this is atomicredteam.com, if you couldn't tell. And I'm going to change my screen. I'm just going to mirror it. Much better. Perfect. So this is atomicredteam.com. You click that link, you go to the repo. Oh, it's fine. I'll stand back up. So here's the repository on GitHub, and like I mentioned, everything's here. There's also basic how to use Atomic Red Team on here in case you've never seen it or heard of, played with it too much. All that data is here. And so for the quick demo, what I'm going to do is what I like to do for Red Canary is this is connected back to our Carbon Black instance, our test one. And so the way to get our analysts to jump is just to start running every batch file in here because they all just go hog wild. So I'm just going to click it. It'll go through. It's going to download that discovery bat file. It just starts executing stuff and just goes crazy. It's not on a domain, so it's going to get hung up on a few things here and there. And nope, keep going. All right, you killed it. So that was it. That's how fast that one goes. You could run other ones as well, and they just go crazy. This is a discovery one, and so it's just going through everything on this box, looking for everything out there, generating telemetry, or trails as we call it. So it's generating information within Carbon Black or CrowdStrike or even Sysmon, and now you're validating. You can go back, look through your data, see if any of this information has been picked up by your tools. We do have some success with AV, mostly picking up everything, especially when we pull in like Mimikatz or whatnot. And so those pieces will come. So this is a Sysmon. Is anybody using Sysmon? Awesome. You guys know what Sysmon is? Okay, cool. So everything's in here. So again, Sysmon's collecting that telemetry that's being executed. So here's a net view command running out of that directory from that batch file, net accounts domain, just querying anything and everything. And this is that discovery bat file just going crazy. Here's that download string. So as simple as that, right? Should be getting a phone call soon. Yeah, that's it. It just keeps going. Within the repo as well, I always recommend checking out like our execution PowerShell technique. It has a lot of really interesting ones in there that I borrowed from like different products like Empire or I think it might just be Empire. But Empire has some really cool things that you can execute that I added in there. You just copy paste them, drop them in. Does some really crazy stuff. It'll download Mimikatz into Notepad, save it, and execute it. Just neat things to see if you actually have detection capabilities for any of these things out there. So, hey, the demo worked, right? So that's impressive. Cool. Anybody have any questions? Shirts? We have lots of shirts and stickers. But yeah, what's up? I have no idea. The question was, how did we bribe Lee Holmes to submit a pull request? From what I understand, he actually is a fan of the project, so he contributed just out of goodwill and helped us out with that. Oh, there we go. Anyway, it's awesome. Yeah. Yep, no problem. There's Atomic stickers and t-shirts up here, Red Canary stickers as well. Yeah, any other questions? Yeah, I always say like, if you have like no visibility or like no budget, you just can't get anything into your environment, like an enterprise tool like Carbon Black or CrowdStrike, minimally Sysmon, just for some visibility. You can up your Windows logging and audit logging and stuff like that too. But again, it could just generate more noise if you're a one-man shop. You don't have all day to look for failed logons and everything, even with Sysmon stuff. The other thing, if you have Splunk, or you can use a free part of Splunk, we also have a Sysmon app. I created a Sysmon app which allows you to kind of go from 0 to 100 real quick just with Sysmon data. So that's a really quick way to kind of win at that front too. So Sysmon's probably your fastest, easy bet to get going. And then over longer term, budget for something more enterprise that you can actually do more with and everything. Yep. Any other questions? Oh, hey, it's dark over there. Yes. Yeah. Yep. Yeah. Yep. So the question was, is there any plans to like add like staging into Atomic Red Team? Right now we haven't added that, but I think that's where like the YAML piece is going to come into play once we get like Meta using it and Caldera and whatnot. We'll probably have better options and availability to like add those pieces for staging it across multiple endpoints, especially like you do like a password spray and then you log into a new box or something. Could be more hands-on too for the one-man shop attacker team, you know, to go through for sure. Yeah, not right now, but yeah, good question. Cool. Any other questions? I'm not saluting, I'm just blocking the light. Awesome. Thank you guys, appreciate it. Thanks for getting up early for me.